Welcome all in class 8 on PCB design course. Every PCB is mounted with some electrical and electronics components to perform a specific task. So in class 8, 9 and 10, we will discuss some of the basic components used in PCB designing. In class 8, we will discuss about the types and applications of resistors used in PCB designing. So, some of the basic resistors which are used in PCB designing includes fixed resistor, variable resistor, surface mount resistor, light dependent resistor, thermistor and varistors. So resistor is basically used to restrict the flow of current in a circuit. Resistors are non-polarized, that is, they do not have positive or negative terminal. The symbol for resistor is as shown in the slide. The important parameters of resistor are the resistor value, the tolerance and the power rating. The resistor value indicates the value of resistance in ohms. Tolerance gives the variation of resistance value from the indicated value. It is expressed in percentage. Tolerance values varies from plus minus 1% to plus minus 20%. Power rating, again a very important parameter for the resistor. So basically resistors convert the electrical energy into heat energy, and this heat energy is finally dissipated into the air. Power rating of resistor indicates the maximum electrical power in watts that resistor can convert to heat energy. If applied electrical power is more than that of maximum power rating, the resistor will produce much heat and will be damaged. Resistors with power rating from few watts to hundreds of watts are available. The voltage and current in a resistor are related by Ohm's law. Let us suppose there is a resistance of value R and a voltage source of magnitude V is applied across this resistance. The current developed into the circuit is I. So by Ohm's law, V is related to R by V is equal to IR. The power dissipated in resistance is given as VI, or V is IR, it is I square R. That is power in resistance, power dissipated in resistance is dependent upon the current in the resistance as well as on the value of resistance. For safe operation of the resistor, the PR, that is power dissipated in resistor, should be less than the maximum power rating of the resistor, because if power dissipated in resistor is less than maximum power rating of the resistor, then resistance will be able to dissipate this heat into the atmosphere. However, if the power generated in resistance is more than the maximum power rating of the resistor, then resistor will not be able to dissipate this heat into the air and ultimately the resistor will damage. So in types of resistor, the first one is fixed resistor. As the name suggests, the fixed resistors are the resistors whose resistances do not change in voltage or with temperature. Generally, carbon composition resistors are used as fixed resistors. A type of fixed resistor is shown in the slide. The value of resistor is calculated from the colored band on the resistor. The value of color band can be determined from the color code value. For example, black is 0, brown is 1, red is 2, orange is 3, yellow is 4, green is 5, blue is 6, violet is 7, gray is 8, white is 9. So the first two bands indicate the value of the resistor in decimal. For example, in the slide shown, the first band is red, so its value is 2. The second band is violet, its value is 7. So resistance is of first two bands indicate that it relates to 27. The third band indicates the multiplier of 10. So green here is corresponding to 5. So the value of this resistance is 27 multiplied by 10 raised to power 5 ohms. The fourth band indicates the tolerance of the resistance. The tolerance for gold is plus minus 5% and tolerance of silver is plus minus 10%. Next in the series is variable resistance. So variable resistance is the resistance whose electrical resistance can be adjusted from 0 to some defined maximum value. A potentiometer is a variable resistor with three terminals as shown. Its three terminals are designated as A, B, C. The position of knob determines the resistance between terminal A and B and between B and C. Next in the series is light dependent resistor. So if resistance offered by resistor changes with the intensity of light, it is called light dependent resistor. So the characteristics of light dependent resistor are as shown in the slide. That is, when light intensity increases, the resistance of resistor changes from higher value to lower value. So in dark, LDR has very high resistance. That is, when light intensity is very low, the resistance of LDR is very high and it may goes up to 10 mega ohms. In light, the light dependent resistance has very low resistance and it may be as low as 100 ohms. So this is the representation of LDR and it is the symbolic diagram for LDR. So the application of LDR includes that these resistors are used in light sensors and their application may include street light controller, light intensity meters, burglar alarm, and etc. So next resistor is thermistor. Thermistor is a resistor whose resistance changes with change in temperature. So thermistors may be classified as positive temperature coefficient or negative temperature coefficient thermistors. In case of positive temperature coefficient thermistors, the resistance increases with increase in temperature. That is, as temperature increases, the resistance offered by the thermistor also increases. However, in negative temperature coefficient thermistor, as the temperature increases, the resistance offered by thermistor decreases. The resistance at temperature T2 is related with resistance R1 at temperature T1 by using the relation that R2 is equal to R1 e raised to power beta in bracket 1 by T1 minus 1 by T2, where T1 and T2 are in Kelvin. The symbolic representation and a real thermistor is as shown in the slide. Next in the series is varistor. So varistor is a type of resistor whose resistance is dependent on the magnitude of applied voltage across them. So when the voltage across the thermistor will change, the resistance offered by the varistor. So as voltage applied across the varistor changes, the resistance offered by the varistor also changes. The properties of varistors include that under normal voltage conditions, the resistance of varistor is very high, and as resistance is very high, so no current flows through it. So during surge of very high voltage, that is, it might possible that there comes a very high voltage signal, that is called surge. So during surge of very high voltage, the resistance of varistor reduces to very low value, and so very high current flows through it. Thus, the advantage of using varistor is to protect the remaining circuit from high current to due to surge. That is, we can protect our circuit due to surge, because when surge will appear, the resistance of the varistor will decrease to infinite small value, and all the current corresponding to that surge will flow into the varistor, and the remaining circuit will be protected from damage. So next in the series is SMD resistor. An SMD is an electronic component that can be mounted directly on PCB circuit board by using surface mount technologies. So SMD resistors are basically used to mount resistors on PCB using surface mount technology, and SMD resistors again are available in variety of values. So this was all that we want to discuss about resistors. Thank you very much.